Today we're going to talk about organizing data. Okay? So what I have here, we're going to call them IQ scores. You guys know what an IQ test is? You ever heard of that? Yeah? Okay, so here are IQ scores. And what we want to do is we want to organize these scores. Now, lucky for you guys, I've already put them from least to greatest. Okay? So there's a couple of things we do want to talk about. First of all, a range. If I was to ask you what the range of the scores were, what would you do to solve this? Yeah, that's right. We're going to take the top value, so I'm going to call it the max. And we're going to subtract the minimum value, okay, to find the range of these scores. In this case, that's 131. Subtract 63. What is it, 68? Okay. So the range of scores on this IQ test, the scores ranged a matter of 68 IQ points. Okay? So we've talked about the range. Now, someone spoke about the 3 M's, which I'm hoping you guys already kind of know what to do. Quickly looking at this, what is the mode? Who knows what a mode stands for? Oh, nobody knows what the mode is? No. Nope. Yeah, the mode is the value that occurs most often. Okay? So most often,
115.
There's only one number that doubled, so the mode in this case would be 115. Okay? The mean is considered the average. I'm not actually going to calculate that. I hope you guys already know how to do that. You've got to sum all the values together and divide by the number of terms. And then the median is actually going to become important to us here. Anyone know what the median is? That's right, it's the middle value. That one's going to be important for what we're about to do next. Now, first off, what we need to figure out is how many terms there are here. How many, Zidane? Good. Daniel, or David, thank you. 16. There are 16 terms here. Okay? And what we're going to be doing is we're going to be splitting them into quartiles, they're called. Okay? So this is going to be important for you guys, quartiles. And the way quartiles work is we have a Q1, Q2, and a Q3. And technically we could have a Q4, but they don't really talk about it that much. And what these are going to represent is all of the data. The first quartile, anyone know what quartile might stand for, what number it's related to? Has to do with like a fraction. What does it sound like? Quartile.
Quarter.
A quarter. Okay? A quarter means what is a fraction? What fraction is a quarter? That's the decimal. 1/4. Okay? Which is known as 0.25. Okay? So a quartile represents 1/4 of all of our information. So we're talking about the first quartile. We're talking about all of the numbers or all of the data in the first quarter or first 25% of the information. It depends how many numbers there are. Because there's 16, you're right. We're just going to be talking about our first 4 numbers. But it depends how many numbers there are in the entire set. Okay? The second quartile, again, quartiles are going to be separated by 25%, right? But the second quartile is going to represent everything from 0 to 50% of the data. In other words, we've added up 25 and 25. Okay, so everything before the second quartile is 50% of the data. Quartile 3, we add another 25%, right? Anything before quartile 3 would be how much of the data? 75, good. And finally, our last quartile, you could call Q4 if you like. That's right. Everything before Q4 would be considered 100% of the data. What we're going to do is work on organizing the data we have into quartiles. So we can decide if it's in the first quartile, second, third, and fourth. And we're going to even talk a bit about box and whisker plots. It's okay. I think it's still working. Okay. So, we have all this information here. There are 16 pieces of data in this set. Okay? To find the median, we need to find the middle value. How can I find the median if there are 16 values? How do I find the middle of this?
Divide by 2. It's the middle.
I can divide by 2. That can help. Okay? And if we were to divide this value by 2, 16, so let's go down and write this down. Okay? So median, we can say take the number of data okay, and divide it by 2. In this case, there were 16. So we divide it by 2, what do we get? 8. So what that means is there's going to be 8 values to the left of our median and 8 values to the right. Now, side note, okay? I'm just going to throw this in. Let's call this example 2 here. Let's say we had 17 pieces of data. We divided it by 2. What value would we get? 8.5. Okay? Now, we don't consider splitting pieces of data. What would that mean, 8.5? We rounded up to 9. So, I'm going to use little pictures here so that I can remember where they are. Oh, yes, that's okay. So let's use little happy faces to help us out here. Let's say we have 17 pieces of data. So here's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17. Okay. Now remember they said 8.5. Well, there is 1, 2, 3, 4, 5, 6, 7, 8 pieces of data here. This will be considered our 8.5. I don't think so. I was right. Oh, does it still work? So this would be the 9th piece of data, and then again we'd have 1, 2, 3, 4, 5, 6, 7, 8. So if there's 17 pieces of data, there's 8 to the left. Sorry, 8 to the left and 8 to the right. The 9th would be the median. Okay? There would be an equal amount on both sides. But because we have an even value, we'll go up to our actual data here, and we're going to count 8. Okay? So we have 1, 2, 3, 4, 5, 6, 7, 8. And then again we have, counting from the right down, 1, 2, 3, 4, 5, 6, 7, 8. There is no piece of data in the middle to have an even amount. So how do we find the median between these values? Not quite subtracting. What we actually have to do is we find the average between these two values. Okay? So we have 99, that's the closest to the median on the left, and 101 is the closest on the right. Okay? We're going to add them together and divide by 2. So 99 plus 101 divided by 2, that's right. What's the median value? 100. So it's not actually in the data, but the median value is 100. The median value is also considered quartile 2. Remember, 50% should be to the left, which means 50% of the data should be to the right also. So the number 100 splits us into quartile 2. Now what we're going to do from there is, now that we've split this, okay, so here are the 8 pieces to the left, and these are the 8 pieces to the right. To find the next 2 quartiles, we're going to do the exact same process. How many values were to the left of the median? 8. Okay? So to find quartile 1, we take our 8 and divide it by 2. So it's going to tell us 4. In other words, we could split this data into 1, 2, 3, 4, and 1, 2, 3, 4. Again, there's no actual value here. There's 4 to the left and 4 to the right. So how do we find this one? We do the same thing we did before. Add them both together and divide by 2. I think that's why it's doing it. Don't worry, I think it fixed. I think I saw that. So we take these two values. We have 90, and I'm just going to make a little room up here. 90 and 85. We'll add them together and divide by 2. That's going to give us 175. So 87.5. So our quartile 1 is 87.5. That's important for us. So we go down to quartile 1. Its value is at 87.5. Okay. And then for quartile 3, we do the exact same thing with the information to the right. We count over, because we already knew it was 8, we divide it by 2, so we have 1, 2, 3, 4. This would be our middle term, 1, 2, 3, 4. So again, there's nothing there, so we have to add them together and find the average. This is going to be 225 divided by 2, 112.5, I think.
So we find the median for each quartile?
Yes, that's right. We'll be finding the median 3 times. So this will be 112.5. Okay? So we've now found values for all 3 quartiles. For quartile 1, anything lower than 87.5 would be in the first 25th, or the first quarter of the information. Anything between 87.5 and 100 would be in the second quartile of information. Anything between 100 and 112.5 would be in the third quartile of information, and anything greater than 112.5 would fall under the fourth quartile of information.
Yeah.